parallelograms are absolutely fantastic geometric objects. I want us to think about it for a little bit because they have so much structure. You can do so much with a parallelogram. It's unbelievable, unbelievable. Anyway, let me tell you something that happened to me. So I was at a picnic a while back, and what happened was a lot of people having fun, playing volleyball, having a good time, and there was this picnic table which had all the food on it, which was great, but it was a really inexpensive picnic table. And so with all the food on it, all of a sudden the legs started to give way a little bit, and we're at the volleyball court, and we look over, and all of a sudden what we see was really, really ominous, because here was the picture. You can see it starting to lean, and that potato salad is not looking good. It's going to be hitting the floor real soon. Anyway, this is what the picnic table looked like, and you can see that it's leaning and actually forms what we think of mathematically as a parallelogram. So this is a parallelogram, which I kind of like this image because really, when I think of a parallelogram, I think of it sort of as like a rectangle that's sort of leaned a little bit. It's been sort of like that. So just think of that image for a parallelogram. All right, well now, let's suppose that I give you a whole bunch of facts about the dimensions, the various dimensions of this particular leaning picnic table. Let's take a look. So the first thing I tell you is that AD, that length, is 60 inches. So AD, so this length right here, that side, is 60 inches. And I also tell you that AE is 35 inches. Now AE is right here, so this little piece right here is 35 inches. Okay? And finally, I'll tell you the measure of angle CDA, so that's CDA, so this measure right here in the grass, this grassy angle, is 81 degrees. So 81 degrees. Okay, and now let's just have some fun looking at this parallelogram picnic table and find various other measures. First, let's start off by finding out what's the length of BC. So where's BC? Well, BC is right here. Well, I noticed that this is actually the opposite side of this AD. And so with parallelograms, we know that opposite sides actually have the exact same length. So in fact, really easily, I can quickly say, since it's a parallelogram, this is going to be 60 inches as well. See, this is the great thing about parallelograms. We have so much wonderful symmetry. How about the measure of angle DAB? Well, let's take a look and see. So the measure of angle DAB, well, that's this angle way up here. You see it? Way up here. Well, how can I think about that? Well, it's a parallelogram, which means that opposite sides are parallel. And we can think of this side AD as a transversal cutting these two parallel lines. And these are interior angles cut by a transversal of two parallel lines. So we know they're supplementary. So this measure plus that measure has to equal 180 degrees. And so I know that the angle, the measure of angle DAB is going to be something such that when I add 81 degrees, I'm going to get 180 degrees. Because these two angles, the measure of those angles equals 180. And so now if I subtract 81 degrees from both sides, I see that the measure of the angle is going to be 99 degrees. 99. Which happened to be the temperature outside that day at the picnic. So 99 degrees is that entire measure up there for that angle. And finally, let's see if we can find the length of EC. Well, EC, that's right here. What you notice is sort of the twin to this part, AE, which we're told is 35 inches. Well, it turns out a great property of parallelograms is that if you consider their diagonals, the diagonals actually cut each other and bisect them. So in fact, this length is the same as that length, and this length is the same as that length. Again, look at all the great properties we have for parallelograms. So since we already were told this is 35 inches, then it's very easy to see that EC is also 35. And so my final measurement is 35 inches right here, because in fact, this diagonal will bisect the other diagonal. Really cool stuff. I love parallelograms, even when we're at a picnic.